All right, so we are in Unit 2 here in AP Stat. We're going over some practice problems, and we're trying to figure out where we are at here right before our test, reviewing some stuff online. Again, um, this whole unit was on like scatter plots and regression lines. So try and review like all the concepts right before the test to kind of get your brain cooking a little bit. If you need some help, remember, pause these videos, write them down, and kind of go over them. And as we go, feel free to pause if you need to, but I do have to move reasonably fast to kind of get through some of this stuff. So anyway, practice problems here. In Unit 2, it says biologists studying the effects of acid rain on wildlife collected data from 163 streams in the Adirondacks Mountains, and they record the pH of the water and the BCI, a measure of biological diversity, and then they calculated the R squared, and here's a scatter plot. So they're giving you the scatter plot, right? Pattern-wise, I don't know if there's a pattern per se, but it does appear for the most part like it's going down. It does appear negative, right? Is what it appears like. So what is the correlation between there, right? Well, the R squared, we square root that. It says, and since it's a negative, put a negative out in front. It says describe the association between the two variables. I would say 27% of the BCI variability is associated with the variability in the pH. Right, and if a stream has an average pH, right, an average pH, what would you predict for the BCI? And in a stream where the pH is 3 standard deviations above average, what would you predict about the BCI? So let's take a look here. The first couple we answered kind of quickly. We square root the R squared in order to find our correlation, and again, because it looks negative, that's why that is negative. And it says the association between them is negative. It's moderate, right? It's negative. It's not really great. It's moderate, right? And it seems linear for the most part, but generally, the higher the pH is, the lower the BCI, right? The higher the pH, the lower the BCI. Additionally, the BCI appears more variable for a higher than it is. So in a stream with an average pH, the BCI would be expected to be average as well, right? I mean, that's just a given. If that's average, that's then predicted to be average. It's no more trickier than that, right? Whatever the average one is here is probably the average one there as well. In a stream where the pH is 3 standard deviations above average, the BCI is expected to be 1.5 standard deviations below. And then some are wondering necessarily how that is given. Basically, in order to get that, what they're saying is if you know that it's 3 standard deviations away, it's the standard deviations away times the correlation, and we found the correlation because we square rooted that. So we would expect that the BCI would be 1.56 below. That's why they're getting the pH level is 3 standard deviations above, then the BCI is expected to be 1.56 but below, because that's negative. So next up, a statistics instructor created a linear regression equation to predict students' final exam scores from their midterm exam scores. The regression equation was this. Your final is 10 plus 0.9, whatever your mid was. If Susan scored a 70 on the midterm, what did the instructor predict? Just plug it in. I predicted a final exam of 73. Susan got an 80 on the final exam. How big is that residual? So she was predicted to get that, but she actually got an 80. So it's above there, right? So according to the model, Susan is predicted to get a 73, but she's 7 points above the residual. So she scored 7 points higher than what was predicted, which is good, right? If the standard deviation of the final was 12 points and the standard deviation of the midterm was 10 points, what is the correlation between them? Well, we can find that because we know the slope. So what they're saying is, remember, slope is that. I know the slope, I know that and that, so I can basically just multiply by 10, divide by 12, and that'll tell me the R. So we ended up getting our R for that. It's positive because the slope is positive. And then part D says, how many points would someone need to score on the midterm to have a predicted final score of 100? If I want it to be 100, put that there, minus the 10, divide. So they would need to also score 100. It says in order to have a predicted final exam score of 100, a student would need to have a midterm exam score of 100 as well. For E, it says suppose someone scored 100 on the final exam. Explain why you can't estimate this student's midterm score from the information given. It says the linear model is designed to predict final exam scores. So remember when we were doing these problems a couple of sections ago, I said that you can't plug it in the other way around. Like, you shouldn't do this. You shouldn't put in the final score. It says in order, how many points would someone need to score on the midterm to have a predicted score of that? So the point they're getting at is they're just trying to figure it out. But if I'm given an actual score, the real score, because this is predicted, I can't plug it in. And that's what E says. Suppose someone did actually score 100. I'm going to have to twist the whole thing around. We have to re-examine it. We have to basically switch the order and plug it the other way in to solve it, because that is what's the predicted score. And no, 100 is an actual score. So in order to predict in this direction, a linear model would have to be generated in that direction with final exam scores as the explanatory variable. And all you would do is switch them, your X and your Y column, on your linear regression equation, and you could do this. Notice that part D is not predicting the midterm from the final, but rather the other way around is all that they're getting at, so it wouldn't work. If one of the students in the class scored 100 on the midterm, but got overconfident, slacked off, and scored only 15 on the final exam, what would that residual be? Well, from part D, a student with a midterm score of 100 is predicted to have a final exam score of 100. Right? What they're saying is, if you did actually score that, right? That wasn't a prediction. It says, what were you predicted? So you were actually that much below 15. So part D, remember when we were doing this right here, part D was saying that how many points would someone need to score on a midterm to have predicted, right, that. So that was your predicted score. That's why we plugged it in there. So this is saying one of the students in the class scored 100 on the midterms. Oh, sorry, right here. From part D, we said a student with a midterm score of 100 is predicted to have a final exam score of 100. That's what we said, right? So the student's residuals, if they only scored a 15, they were below by 85. And no other student in class achieved such a dramatic turnaround. If the instructor decided not to include this student's score when constructing a new regression model, will that R-squared value of the expression increase, decrease, or remain the same? So what they're saying is, if that wasn't there, because that's really far off, right? That R-squared of the value of the regression would increase because that was so negative that it's pulling it down. That point would be pulling it down. So the student's large negative residual would detract from the overall pattern, allowing the model to explain less of the variability. So removing it would increase the strength, right? Because it's so far away from the residual pulling it down, it would actually increase the strength of our association between them. A statistics instructor, again, creates this. H, will the slope of the new line increase or decrease? If we were to take that away, it says the slope of the linear model would increase because I'm taking that point away. So the student's large negative residual would pull the regression line down, perhaps even make the association appear that it's negative. Removal of that point would allow the line to snap back up to a more true positive association, is basically what they're saying. On Thursday, researchers gave students enrolled in a section of basic Spanish a set of 50 new vocabulary words to memorize, and on Friday the students took a vocab test. When they returned to class the following Monday, they were retested without advanced warning, and here are the test scores for the 25 students. So on Friday their score, and then Monday their score, and Friday and Monday, right? What is the correlation between Friday and Monday? So you put your list down 1, list 2, and then you plot them using line reg to see what shows up. So the correlation between them using line reg is that right in the button, period. That's all you got to do. Then it says, and all I did was put those all in list 1 and those all in list 2, and then go to line reg. It says, what does a scatter plot show of the association between them? Well, scatter plot, if you were to plot it, let's see if it's on here at all. I don't know if it, yep, there it is. The scatter plot is looking like it's positive if you were to plot it, but it does kind of, it's not strong. So that's why they're saying it appears as though it's positive. Let's see here what they say. The scatter plot it was positive, it was linear, but it did seem kind of weak, right? So then it says a student with a positive residual scored higher on Monday's test than the model predicted, right? So, what does it mean for a student to have a positive residual? They scored better on the test than was predicted. They scored better on the on Monday's test. That was the second one. They scored better on the Monday test than they did on what it was predicted for them to score, basically. And then D, a student with a Friday score that is 1 standard deviation below average. So a student with the Friday score, 1 standard deviation below average, is expected to have a Monday score that is 0.473 standard deviations below Monday's score. Because it says, what would you predict about a student whose Friday score was 1 standard deviation below average, right? If this was 1 standard deviation below average, if that's what their score is. And it says that in 1 standard deviation below average is expected on the Monday score, that is 0.473 standard deviations below, because you can look at your data to see that the distribution of scores from Monday have mean of 37.24 points and a standard deviation of 5.02, and you can get that on the Monday scores by adding them all up on the calculator. You put them all in, and then you find the value, your one variable stats of this, right? You can find the mean and the standard deviation. So the student's score is predicted to be, which we just set up with the z-scores and stuff to get the predicted line here. But the point is, you have your R, and you have your equation of the line. So when you plot it all, you would find what the equation of the line is with your line reg, which is here anyway. You would plug that in to find your answer. With your regression equation, it says right here, write the equation, the linear model that predicts Monday scores from Friday, right? Because Friday is what you plugged in, and then predict the Monday score of a student who scored a 40 on Friday. So if we were to plug in 40, that would be your score. So according to the model, a student with a Friday score of 40 is expected to have a Monday score of 36, basically.